All right, folks, so we have now we're able to identify the type of reaction. So what we'd like to do next is more sophisticated, and that is to predict the products. So we can take the reactants, decide how they're going to react, what the products are going to be. So we'll start with acid-base neutralization reactions on page 5.11. And that silly joke I've been making since the beginning about Professor Paula Abdul still works. So here I'm recognizing, I'm on page 5.11, if I look at reaction A, I recognize that as an acid base. There's my acid over there. There's my OH minus. We're back to chapter 3 saying, oh yeah, that's right, I recognize this. So I'm going to break this down. Since that says aqueous, I'm going to write CS plus, and I'm going to write OH minus. That's what that is in water. Now, this is an acid, a strong acid. I'm going to do something similar, and I'm going to cheat just a tiny bit here. I'm going to write it like that. Now, that's a teeny fib, but it works perfectly fine for Chem 51. So that's what I've got in water. Professor Paula Abdul says plus sticks to minus. And we already know, we'd say, well, that's right. We expect to get water, and we expect to get an ionic compound. So if I do this, here's what I've got. CS2SO4, aqueous per our rules, and H2O liquid. Easy. I had to remember that. For an acid, I'm really thinking about H+. There's my silly Professor Paula Abdul, opposites attract. Check out the video. When we say neutralization, that means there's no acid or base left over. So we could balance this, and we're sort of getting clever at balancing these and not having to do every single element. But one of the things I'm going to notice, well, I've got cesium there, I've got 2 of them and 1 here. So I might try this, and well, I know that's going to work. Do that. I've got now 2 of these hydroxides and 2 of those hydrogens. That's going to give me 2 waters and 1 like that. Now you can go through that and balance element by element. It'll be just fine, but you'll probably start to see shortcuts. So let's try the next one. B. I'm going to do the same trick. Ca2 plus hydroxide H plus CH3 CO2 minus. That is, of course, acetate. Now, I didn't worry about quantities. I just took the cation and anion from each one and said, well, okay, that's right. I'm going to get water, and I'm going to get an ionic compound. So I could say I'll put this Ca CH3 CO2 2. That's aqueous, and I've run out a little bit of room there. But there we go. Ionic compound and water, just as we've been saying all along. Let's see, I go over here, I see there's actually 2 hydroxides there. So I'm going to expect that I'm going to need 2 of the H pluses to make that work. That's going to give me 2 waters. Calcium's balanced now. If I look at this whole thing as acetate, I see 2 acetates here, 2 there. I think our numbers are just 1 and 1. Bingo. Active ingredient in an acid. There's my base, has a negative charge. There's a cation and an anion. Boom. Ionic compound and water. Now it's going to get a little more interesting. this reaction C is quite different. I'll do the same trick. Sodium ions, bicarbonate ion. There's my HBr, strong acid, H plus, Br minus. Well, I'll do this. There's my ionic compound. Now, I don't see how I'm going to get water out of this, but Professor Paula Abdul says those two are going to go together. So I'm going to move this down here just to give me more space. So I'm going to say, well, I've got NaBr. Sodium compounds are always aqueous. I'm water soluble. Now I've got this sort of weird looking thing. I'm just going to say, well, there's H plus. That's from an acid. There's something negative. That's what's got to stick together. That's what I've got. Now it turns out this decomposes. What's the other thing we expect from water? We expect an ionic compound, and from water. Nice. What's the other thing we expect from an acid-base neutralization reaction? Well, we expect an ionic compound, and we expect water. Well, I don't see water there, but what if we did this trick? I'm going to say, okay, let's take water out of that. We really know that no matter what, we're getting water. Well, what's left over after you take out H2 and 1 oxygen? There it is. So I have to remember, okay, there's my ionic compound. I took the cation and the anion. There's my H plus from acid. It's going to react to something negative. I get H2CO3, and that doesn't look right. So I say, oh yeah, my flashcard said I should get an ionic compound, I should get water, and maybe I'll get CO2. If I take the H2O out of there, bingo, there's my CO2. So, let's see, I know that's liquid, and there's my fizzing gas. And I believe this is all 1 to 1 to 1 to 1. Yes, it is all 1 to 1 to 1 to 1. Now, there are the rules at the top. Active ingredient is H+. It wants to stick to something that's minus. So I think, okay, that is going to stick to something minus. Professor Paula Abdul rule again is, well, the cation and the anion are going to come together to make the ionic compound. I balance it so I don't have any acid or base left over. And there's something new to us. We have to know, the flashcard basically, it says, oh yeah, H2CO3 decomposes into water and CO2. But we already knew we'd get CO2. We already knew we'd get water, and then there's the CO2 left over. Okay, that's page 5.11. The next page I'm going to after this is 5.12, which is an introduction to net ionic equations. Okay, I'll see you at the next video.